All right, so here's your linear and quadratic practice packet. I hope you find this simple, but we're going to do it together. Anyways, so question number 1. 3x subtracts, can you solve a linear equation? So we're trying to isolate the x. We're going to inverse what we see around it to get it by itself. So we're going to add 6. That's 18. We're going to divide by 3, and that's perfect. Here we have to distribute first and then combine like terms. So let's make sure we distribute correctly. Then let's make sure we combine like terms correctly. And then add 34 to the other side. All right, number 3. I know these are simple. I'm hoping they're simple. Solve the equations by the square root property. And if possible, simplify the radicals or rationalize it. So the square root property, we're going to isolate the x squared. We have no linear term here. So we're going to divide by 2. So half of 72 is 36. And then we take the square root of both sides. That's the square root property. And understand when you solve a quadratic, the answer could be positive or negative. That's simple. Same thing here. We're going to solve this by taking the square root to both sides. Again, we're going to recognize the answer could be positive or negative. When we add 7 to the other side, we have to do two things. 7 plus 8, I got that. 7 take away 8, and I got that. So you have 15 or negative 1. Is the square root of 16 8? 4. Let's try it again. 7 plus 4 is 11, and 7 take away 4 is 3. So 11 and 3. Here it is. You probably did a better job than I did. Number 5, can you solve it? Now this one's a trinomial, so you can't take the square root here. Instead, we're going to factor it right as a product. So because it's simple, just get to it. Two numbers that multiply to negative 20. Because it's negative, you're subtracting. So it's 8. So those two numbers are 10 and 2. And it would be negative 10 and positive 2. So negative 10 and positive 2 add to negative 8, and they multiply to negative 20. Then each factor equal to 0. So the first factor will give you the answer 10, and the second factor will give you the answer negative 2. Number 6. Again, we're going to factor. Two numbers that multiply to 16, add to 10. That would be 8 and 2. Take each factor equal to 0. So one answer is negative 2, and the other answer is negative 8. These will be a little more challenging for you. Can you solve by completing the square? So this one's not factorable. So, but could you solve it by completing the square? So let's do it together. To complete the square, I'm going to first subtract 53 to the other side. So I'd like the constant on the right side. Then I'm going to do the linear coefficient. And I'm going to take that. Sometimes it's b, like a, b, c. B, we're going to divide it by 2 and square it. So can you do those two things? What number do you get? So when you divide by 2, you get 8. And then when you square it, you get 64. So that number 64 gets added to both sides. So again, this is 8 squared. That's where 64 comes in. So we're going to add 64. By adding that number then, I made this a perfect square. What number adds to 16 and multiplies to 64, and that's 8 and 8, so I can write it as a perfect square. Then negative 53 and 64, that's 11. Now you can do that square root property, so that x plus 8 is equal to plus or minus the square root of 11. And then the last step is to subtract 8. And they're unlike numbers, so they can only go beside each other. Let's try that again. Complete the square. So I'm going to go x squared plus 10x. I'm going to leave a space, and I'm going to subtract 4 to the other side. I'm going to take 10. I'm going to divide by 2 and square it. That's going to give me the number to add to both sides. So that's 5 squared. So that number is 25 that I need to both sides. And whatever I do to one side, I need to do the other side. Factor this. Two numbers that multiply to 25 and add to 10. That's 5 and 5. It's a perfect square. And now on the right side, it's 21. Now you can do the square root property and solve it. So it's positive or negative root 21. Subtract 5. And and you have your answer. All right. Now, for this one, you could do complete the score, but we're going to practice the other way, which is if you can't factor it, how about the quadratic formula? So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So a story, sometimes I say, is the negative boy couldn't decide whether to go to the dance because the boy was square, so he missed out on 4 awesome Canadians, and the dance was all over at 2 a.m. That's a way to remember it. So a is the quadratic term, that's 1, or quadratic coefficient. B is the linear coefficient, and C is that constant. Make sure it's equal to 0 when you put those numbers down, and then off you go. So B is negative 6. Make sure you use parentheses. A is 1. C is 13. And then just simplify it. That's positive 6. This is 36. Take away, now 4 times 13 is 52. And 2 times 1 is 2. 36 take away 52. That's negative 16. So the solution to this is complex, imaginary. So what is the square root of 16? And the square root of a negative number is imaginary, so it's 4i. And then 2 goes into both evenly. So 6 divided by 2, 4 divided by 2. And you get your answers. Both are complex. Let's look at number 10. So I'm going to solve this by using the quadratic formula. So a is equal to 1, b is negative 8, c is 25. So to solve this, the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. A negative and a negative, that's positive 8. This is 64. I'll subtract 100. So this is going to be complex again. So 64 take away 100 is negative 36. The square root of negative 36. That's imaginary. The square root of 36 is 6, but it's I because it's negative. And then again, 8 divided by 2, 6 divided by 2, and you get your answers. 4 plus or minus 3i. Some graphing. You know how to graph a line? Yep. So 2x plus 2, how would you graph that? Understand the slope is 2, and because it's graphing, it's probably helpful to have a fraction. And the y-intercept is 2. So you start at the y-intercept and then follow the direction, which is up 2 and to the right 1, and then draw your line. Again, number 12, negative 3x plus 2. The slope is negative 3. Write it as a fraction. The y-intercept is 2. And then when we graph this, you start at positive 2 and then go down 3. And then to the right 1, and then draw your line. Now 13 is not in the same form. So there are different ways we can do this. So you could solve for y, but why not try a different way to do this? So a different way to do this is to find the x and the y-intercepts. Well, let's try a different way. So if I'm going to find the x-intercept, you put in 0 for y. So if y is 0, you're left with 7x is equal to 42, divide, and the x-intercept is at 6. For the y, plug in 0 for x, and you're left with negative 6y is equal to 42, divide. And now the y-intercept's at negative 7. And you can draw your line. Here's another one. We'll just use intercepts. So to find the x-intercept, you're left with 6x equals 48, divide. So the x-intercept is at 8. The y-intercept, you're left with negative 8y equals 48. Divide, and you get negative 6. Connect. And you're gone. Perfect. 15. Can you graph parabolas? So what form is it in? So this is in a HK form, which makes it a lot simpler. So in HK form, the vertex is right there, which is -5 and 3. -5. Silly me. So inside the parentheses, the sign changes. So +5 and +3. So let's find that. That also creates the axis of symmetry. So we can draw that in. So the parabola is perfectly cut in half with that a line. I think it's easiest just to do a table of values from here to get other points, and then we can just be done with it. So we already have 5 as the vertex. So what would happen if I put in 6? So plug in 6, and you get 1 plus 3. So can you find 6, 4? And then reflect, and you have another point. Put in 7. Just keep counting from the vertex. So 7 take away 5. That's 2 squared, 4. So that gives me 7. And then reflect. Up just a little more. Try to look at those dots. Try to look at their little grid, making sure I counted correctly. And then reflect on the other side. 16, same idea. Do you recognize the form that this is vertex form or HK form? So right away, might as well do a table of values right away. Right away I know the vertex is at 2, 3. So find 2, 3 and the axis of symmetry. Then I just count from the x coordinate of the vertex. So the next one I'm going to plug in is 3. That's 3 take away 2, so that gives me 4. And then reflect on the other side. Go up another x value, 4, just count up. That gives me 7. And then reflect over. And then draw your parabola. Now what happens when it's not in vertex form? Well, when it's not in vertex form, there's a formula we can use to find the vertex quickly. So the formula to find the x value of the vertex is -b over 2a. So in this example, b is 4, so it's -4. A is 1, so it's 1. So it's -4 divided by 2, which is -2. So we're going to do a table of values starting at -2. Oops, that's x, that's y, -2. So what happens when I plug in -2? This takes a little more time than when it was in HK form. So I get 4 take away 8, -4, which is -11. So my vertex is at -11. So I'll find -2 and -11. It's on my graph. Also do the axis of symmetry there. So it helps me find one point I can just reflect over. I'm just going to count up to make it easier. -1. So if I put -1 in, do some mental math. That's 1 take away 4 take away 7. That's -10. So -1 and -10. And then reflect. Plug in 0. That should be simple. If you plug in 0, you're just left with -7. And reflect over. You can keep adding points if you want. +1. It's good practice. So that is 1 plus 4. That's 5 take away 7. That's -2. Oops, a little higher. And then that's plenty. Get the idea of the direction of it. Let's try that again. 18. What happens when it's in standard form, not in HK form? How do you find the vertex? So we use a formula. So again, the formula is -b over 2a. So for this one, it would be -5, and then 2 times 1. So that's 5 divided by 2. That's 2.5. It's going to be a little bit more challenging. So I would use a calculator and calculate it. So plug in positive 2.5 back in here. Use your calculator, and you should get the answer negative 5.25. So we're going to start there. So 2.5 negative 5.25. So I'm going to estimate where that is. And then draw the axis of symmetry that goes in the middle of those dotted lines. So there's my vertex. I know it's going to fold up. I'm not going to pick point nothing. I'm going to pick like whole numbers here. So 3 or 4 or 5. So if I plug in 4, something simple that you won't need a calculator for, 16 take away 20 plus 1, that's negative 3. And then reflect on the same line. You could also put in 5. That's 25 take away 25. That just leaves me with 1. And then again, reflect over. And you have your parabola. All right, number 19. Can you write an equation in slope-intercept form of this line? So I need to know the slope. So it's negative. So how many down and how many to the right? So it's negative 5 over 1. What's the y-intercept? Where it crosses the y-axis. If you count, that's 8. So just put it together, and it's negative 5x plus 8, and that's the equation of that line. That's in the slope form y equals mx plus b. So again, can you write the equation of this line? So what am I looking at? 2 points. What's the slope? Up how many, and to the right how many? So if you count it, it's 8 up and 1 over. Oops, that's not y, that's m. The y-intercept, where does it cross the y-axis? That's a negative 5, and then put it together. So it's y equals 8x subtract 5. That equation matches that line. Find an equation of the line, and we're going to practice writing in HK form because it's so much simpler. So we're given a slope and a point. How would I write the equation? So let's just follow this pattern through. So in HK form, it's in this form. So I'm going to follow that form in. That's when you have a point x1, y1, and a slope. So if I follow that for this one, I'm simply going to go slope, what is it? 2. The x-coordinate, change the sign, and then the y stays the same. And if I practice that enough, I can very quickly write an equation of a line, which will be very helpful in calculus. So let's do it efficiently. Here we go. What's the slope? 3. What's the x-coordinate? Change the sign, and then the y stays the same, and it's done. Now for 23, you have to just do one thing first. I don't know what the slope is. So what's the slope formula with 2 points? And it's y2 minus y1, x2 minus x1, and then solve that. So I take the y-coordinates, subtract them, the x-coordinates, subtract them, and I get negative 5 and negative 1. So 2 negatives make it positive 5. And then when I write my equation, I have a choice. So the slope I start with, which point? I'm going to pick the first one. Change the sign, keep the sign, and it's over. 24. Again, I need to find the slope. How do I find slope? y2 minus y1, x2 minus x1, and then solve it, and the slope is 7. So I'm just going to take the first point, though you could take the second point, and then write the equation. Change the sign, keep the sign, and it's over. The word parallel means the slope is the same. So our slope is 5, so our equation then would be 5, and then take the point, change the sign, keep the sign, and it's done. Perpendicular means opposite and reciprocal. So the slope is 4, but it's positive. So perpendicular means it will now be negative, and then you do the reciprocal. So you have to do two things. You need to do the opposite sign and flip it. So that's why it's negative a quarter. And then the equation would start with negative a quarter. The x-coordinate, change the sign, and the y-coordinate stays the same. Again, perpendicular, that means they meet at 90 degrees. So what slope is given? How do I find a perpendicular slope? Change the sign and flip it. So it's positive 1/3. And then the equation would be positive 1/3. And you change the sign, keep the sign. And you have the equation aligned very quickly and efficiently and not having to do a lot of work to it. Number 28. So I'm going to graph this piecewise function. So to graph this piecewise function, we're going to take each piece and know how to graph it. So the first piece is when x equals 0. So when it's less than or equal to 0. So I'm going to plug that in. So plug 0 in and find that. That's -1. So find 0, -1. But we're only going to graph, and the slope we know for the top one is 5. So I would count up 5 and to the right one, but I don't want the graph to the right. It's when it's less than or equal to 0. It's when it's to the left. So not up 5 and over 1, but down 5 and to the left 1. We're going to go in the exact opposite direction so it stays on the same line and only graph that part to the left. Then the bottom piece. The bottom piece is when it's greater than 0. So again, I'm going to plug 0 in because I need to know, first of all, where it starts. So I'm going to plug 0 in right where it splits into two lines, and you get -5. So I'm going to find 0 and -5. But this is not going to be a point, but a hole. So why am I doing a hole there? Because the bottom piece is only greater than and not that equal to part. Now I only want the graph to the right. So the slope here is going to be helpful. It's 1/3. So I'm going to count from here up 3 and over 1. And then draw it. Let's try the next one. Piecewise. So 0 is the breaking point. So I'm going to first plug in 0. So at 0, 2, notice it's only less than. It's going to be a hole. The slope of that line is -1. And I can make that a fraction. Now if you go down 1 and to the right 1, you could graph it. But I don't want to go to the right. I want less than. So I'm actually going to go up 1 and to the right 1. No. Up 1 and to the left 1, where it's the same slope, but it's on the left. So normally you go down and to the right. Instead, I take it and I look at it like this. This means go up 1 and to the left 1. Now I do that so that the domain restriction, I only want to graph it when it's less than 0, when it's to the left. And that allows me to graph it to the left. Now the bottom piece, plug in 0. And you get -4. So can I find 0, -4? Notice there's a line underneath that arrow. So it's a point at 0, -4. And then the slope of that line is 3. And to the right side, I can just do the slope and graph it. So up 3 and to the right 1. And that's it. Only graph from 0 to the right of this line. One more time. Graphing a piecewise. So in this piecewise, the slope is 1. You plug in 1, and you get the answer 5. Now, it should be a hole right there because of the less than part, and the slope means I go up 1 and to the right 1. But instead of that, I'm going to do this. Means the same thing, But if I go down one and to the left one, then I can actually draw it. So, and that's a hole right there because it's just an arrow. Now the bottom piece, I'm going to plug in 1, and I get 7. 1, 7 is actually going to be on my graph. Did I count too much? 1, 5 is right. 1, 7. Here, this one's solid. And the slope there is 7. Now, the problem with that slope is that's going to be way off my graph. So if I go up 7 over 1, I can't do it. So, well, and I have to because I can't go the other way, so it's only the left. So I have to count up 7, so I'll just going to do it. 1, 2, 3, 4, 5, 6, 7, and over 1. That's kind of what it looks like, and you have it, even though it goes way off your graph at that point. All right, I'm going to stop the video now. We have a handful more questions to do. So next video, we'll finish it off, 31 to 37. Again, easy, or to 40. Easy lesson today. I'm glad it's a review. I'm glad it feels comfortable. I want it to feel comfortable. Mr. G Math, over and out until next time.